Hi, everyone. I hope you all had an amazing weekend. Welcome and happy Monday. We have our agenda for today are do now, video lesson and slides, vocabulary review, independent practice, and then your exit ticket for the day. We have your standards here. You can go ahead and read these silently independently. Analyze and solve pairs of simultaneous linear equations. You can pause it and go ahead and look through those. So the very first objective here, yes, we we've already really gone over this, but I still keep it there because it is something that we're all still working on as well. Okay, our second objectives is we will be able to learn the substitution method for solving a system of linear equations, and we'll use properties of rational numbers to find a solution to a system if exists through computation. Okay. Now, another computational method of solving linear systems, right? And the same thing we just said in the objective is the substitution method. So your vocabulary for today, that will be some of them again, easy, straightforward, you know the definitions of, but again, these are just vocabulary words that we'll be using throughout the week. So substitute, eliminate linear equations and systems of linear equations. Okay, so to substitute is to use or add in place of. To eliminate, to get rid of. Okay, you want to get rid of something or take away its value, eliminate it. Now, for our very first example, and it's going to be extremely helpful for your independent practice, I'm going to show you all how we actually use the substitution method with a system of linear equations. This example is also in your independent practice in the document itself. So you can take notes from here, but it's also in your document as well. I also have attached the slide to show to this. So example problem 1, we have y equals 3 minus x and 3y plus x equals 5. Okay, these are both of my equations. My step 1 is to ask yourself, are my x or y values isolated? Do we have a value for one of those variables? So in this case, right, when we say we're looking for a value for one of those variables, that variable has to be isolated. It needs to be by itself on one side of the equal, on one side of the equal sign. In this case, right, my y equals 3 minus x, right? I do have a variable that is isolated, my y, okay? So the value of y in this case is an actual expression, which is 3 minus x, okay? My step 2 is to take that y value, right? Since I have that y value already isolated, and plug it into the second equation. So I take this value here, 3 minus x, and I plug it into this second equation here, where my y is. Okay, and this is the result that I get. I get 3 times 3 minus x plus x equals 5, right? And I just bring down the rest of that equation over here. Again, I substituted my y value here and plugged it into my second equation in order for me to get this x value, okay? In this case, right, solve for x. This is a lot. I'm going to go through it word for word, so please just pay close attention. In this case, I did my distributive property. 3 times 3 is 9. 3 times negative, okay, remember we need to take that sign in front of it, x, is, my apologies, negative 3x. Bring down the rest of my equation, plus x equals 5. This then becomes 9 minus 2x equals 5. Where did I get this 2x, negative 2x from? I combine my like terms, 3x and x. So negative 3x plus x gives me negative 2x. Remember, take whatever sign is in front of that term. Whether it be a plus or a minus, that is going to tell you whether the number or the term is negative or positive. Now I'm here. 9 minus 2x equals 5. Take 9, right? Our goal when we're solving for a variable is to isolate x. Okay, so we take our 9, positive 9, subtract 9, bring that to our right side of our equal sign. Again, I bring down the rest of my equation. 9 minus 9 is 0. Negative 2x equals 5 minus 9. I brought down that 5 minus 9. Combine like terms. 5 minus 9 is actually negative 4. Bring down the rest of my equation. Negative 2x equals negative 4. Last step for me to isolate this x is to divide. My opposite operation or my inverse operation of multiplication is division. Okay, in this case, I divide both sides by negative 2. My x becomes positive x. Negative 4 divided by negative 2 is positive 2. Now, this is a multi-step problem. Yes, you found your value of x. We know that x equals 2. Plug in your value for x, right? Because we're finding a solution. We want to find a solution. We need it in x and y form. So you're going to take your value of x and you're going to plug it into one of the two equations and solve for y this time around. Again, it doesn't matter which equation you choose. It is completely up to you. You can pick your first equation or your second one, plug in your x, okay, and solve for y. In this case, I chose the first equation. It's a one-step equation. It's not a multi-step equation. So I chose the first one. Y equals 3 minus 2. Again, I replace my x with 2. Y equals 1. 3 minus 2 is 1. I got my value for y. Your final answer needs to be in the form of a coordinate point. This is where your lines intersect. This is where your lines meet. That is your solution. Okay, 2, 1. Okay, in this case, my x is equal to 2, y equal to 1. Okay, so you need to find both values of that both values of the variables. Again, you can take your linear equations and you can actually plug that into your graphing calculator to check your answer. Another way to check your answer is by plugging in your variables and making sure that your equations are valid, that they're true. Okay? Now, again, you can rewatch this as many times as you please. You can go over it in the Google document, and I also have attached the actual slideshow to this. Okay, so you'll be able to go through the slideshow. It's in a PDF form and go over this again. Okay, please make sure you complete your vocabulary and then your independent